Hello everyone. Let's look at exercise 9.2 circles chapter class 9. Look at question number 2. It says if two equal chords of a circle intersect within the circle. We have two equal chords which are intersecting within the circle. We have to prove that the segments of one chord are equal to the corresponding segments of the other chord. Now what do we understand by that? Let's understand. Let us just understand what is given to us understanding it through the figure. We are given two equal chords. We have a circle over here. Let us consider the center of the circle and let us consider any two equal chords. Say, for example, we say chord AB and we have chord CD. Okay, we have one chord AB and we have the other chord CD and they are intersecting within the circle. The two chords have to be equal, children. So let's mark them the way. We have two chords AB and CD. They are intersecting within the circle. Let me call that point as say P. Let P be the point where the two chords which are equal are intersecting. We want to prove what? The segments of one chord. Now, what are the segments of chord AB? Because of the intersection, the chord AB has been divided into two segments, AB, AP and PB. Likewise, chord CD has been divided into segments CP and DP. So, we are given over here that in the circle with center O, radius OA, chord AB is equal to chord CD. That is given to us. The two chords are equal. What we want to prove? The segments in which they are divided. The bigger segment of chord AB is AP and the smaller segment is BP. Likewise, the bigger segment of CD is CP and the smaller segment is DP. We want to prove that these are equal. I hope the question is understood. We are talking about segments and we are talking about the length of the chord. So we need a construction over here, children. What will be the construction? The construction will be dropping perpendiculars. So let's drop a perpendicular OL on chord AB and OM on chord CD and join OP. We want to prove AP. Understand now. AP is what? AL plus LP and CP is CM plus MP. When we drop a perpendicular from the center to the chord, it will bisect the chord. Means we've already got AL is equals to BL, or we can say AL is equal to LB is equal to half of AB. Similarly, CM, because OM is perpendicular to CD, CM is equal to DM is equal to half CD. Am I understood? So let's understand by writing it. We'll write construction. What is the construction done? We have written OP. I'm sorry. We will write draw OL perpendicular to chord AB, OM perpendicular to chord CD, and we join OP. Now, because of that, we can start with the theorem. With this proof. What is the proof going to be? First thing that we've done in construction, we've written that OL is perpendicular to AB. Now, because OL is perpendicular to AB, can we not write AL is equals to LB and each is half of AB? Similarly, OM is perpendicular to CD. So, we can write that CM is equals to MD is equals to half CD. What other information do we have? We already know that AB is equals to CD. This is given to us. And why are we able to write these two statements? Why? Because perpendicular from the center of the circle to the chord bisects the chord. Right? That is the reason that we are going to give over here. If AB is equal to CD, which is given to us, can we write half AB is equals to half CD? Correct? Now, if I want the part as AP, the first segment I'm looking at is AP and CP and CP. Now, if you look at AP, which half of AB is included in AP? AL. This part is included, na? So, I can say, we can write over here that instead of AB, I can say AL. For now, we need AL, so we are writing AL. We may need the other part as well. Or let us write it both ways, right? Let us write it as two ways. We'll write it as, this would mean that there are two parts. First, first half of AB I'm taking as AL, and the second half I'm going to take it as LB. So we can write AL is equals to half CD. Which half of CD? We are going to take AL with CM, and we are going to take LB with MD. Now why? Because when I look at AP, I have AL plus LP. When we look at CP, we had CM plus MP, means AL corresponds with CM. Correct? Now, again and again, we are doing the same thing. We are saying AL plus LP. We have already proved that this part is equal to this part. Now, the remaining part is LP. If we manage to prove LP is equal to MP, equals added to equals, the wholes are equal. Correct? So, we'll first try to prove that LP is equals to PM. Now, LP is part of which triangle? We know LP is part of triangle OLP, and MP is part of triangle OMP. Can we prove that these two triangles are congruent? Let's mark what is equal. We know that because the chords are equal, their distance from the center is going to be equal. Equal chords are equidistant from the center. OP is the common side, and angle L is equals to angle MY because each is 90 perpendiculars. So we get that the two triangles are congruent by, correct, RHS, right hypotenuse side. And because they are congruent, the two triangles, now we can say that LP is equals to MP. I hope I'm understood, children. Right? Let's write it. How are we going to write this now? Which part are we taking? We are going to write here. Consider triangle OLP and triangle OMP. What is equal? We need three parts for proving the two triangles to be congruent. We have OL is equals to OM. Why? Equal chords are equidistant from the center of the circle. Are equidistant from the center of the circle. I hope you remember this theorem. Then we write OP is equal to OP. Why? Because it is a common side. It is a side which is common to both the triangles. And we have angle L is equals to angle M. Each is 90 because they are perpendiculars. Hence, what do we get? We get triangle OLP is congruent to triangle OMP by which test? Very good, RHS. And because the two triangles are congruent, we can say LP is equals to MP by CPCT. Now, why is this property so important? Why is this part so important that we need to prove LP equal to PM? Now, let's look at it again. Okay. Let's understand why LP is equal to PM, an important part of this proof. Right? After we prove this, we'll say now consider, what do we have? We have AL is equals to MC. We have already written that from here. And now we have LP is equals to PM, proved above. If I add them, what do we get? AL plus LP will give me AP, and MC plus PM gives us CP. Likewise, if instead of taking AL, if I've taken LB is equals to MD, this part. And again, we have LP is equals to PM. But this time, instead of addition, if we subtract. Now look at this. We have LB. From that, we are subtracting LP. So we are left with PB. Similarly, we have MD. From that, we are subtracting MP. So we are left with DP. Hence, we got what we wanted to prove. We wanted to prove AP, the segments. AP is equals to CP and DP equals to PB. I hope you all have understood this. Let's look at the next question. Let's understand the next question, children. If two equal chords, it's very much related to what we are doing. Okay. what we have already done, not doing what the question that we have done, exactly same. We have a circle. What is given to us in the circle? If two equal chords intersect within the circle, if two equal chords are intersecting within the circle, so we have the center of the circle, we have two equal chords again, right? Let us consider these as two equal chords. Say chord AB and chord CD are two equal chords. What is given? Chord AB is equals to chord CD. We have to prove that the line joining the point of intersection. Now, which is the point of intersection? Say P. The line joining the point of intersection to the center of the circle, OP, makes equal angles with the chord. This OP makes angle OPA with the chord AB and OPC with the chord CD. We want to prove that these two are equal, these two angles. Now, again, what do we understand? If we want to prove that, we'll have to do a construction. We'll drop perpendiculars. And let us call this as OL and OM. We want to prove, first we need to prove that angle OPM is equal to angle OPL, or can also be written as angle OPA is equals to angle OPC. Instead of M, you write C because they are collinear. I hope it is understood. What construction did we do? We are doing a construction OL perpendicular to AB, OM perpendicular to CD, and then we are saying we'll join O to P. Now, does this not look very similar to what we did just before this question? We'll just prove that triangle OLP and triangle OPM are congruent. So we'll write here in triangle OPL and triangle OPM. Can we write three congruent parts or equal parts? Sorry. We have what? OP is the common side. OP is equal to OP. We'll write here common side. We have angle L is equals to angle M. Each is 90 because it is perpendicular. OL perpendicular to AB and OM perpendicular to CD. So each becomes 90. Then, since AB is equal to CD, this implies that OL is equals to OM. Why? Equal chords are equidistant from the center of the circle. So, what do we get then? Triangle OLP is congruent to triangle OMP. By which test? Very good, by RHS. And because the two triangles are congruent, we can easily say that OPA or OPL is congruent, is equal to angle OPM or OPC, and the reason being CPCT. I hope you all have understood this, children. We got the solution. It was a part of the previous question also. I hope this is understood. In the next video, I shall explain the question of three friends sitting on the boundary of the park at equal distance. Ankur, Sayyed and David, right? Meet you in the next video. Thank you.